Hello! This video is about limiting reactants, how we can find them, how we can use that to calculate the excess reactant that's left over, and then overall how we can look at the percent yield of any kind of reaction. Okay, so to start with, what's a limiting reactant? I want to focus your attention on the left-hand side. You can see there's a race car here, and according to the race car, you need all these parts. Assuming you have, as you can see number 1, 15 cylinders, that's these square-looking things. Assuming you have 15 of them, and an unlimited supply of everything else, how many complete race cars could you make with 15? Well, I can see each race car needs 3 cylinders, so if I have a total of 15, 15 divided by 3 equals 5. I can make 5 race cars. Then I'm going to run out of those cylinders. Let's look at the bin in the bottom. How many race cars can I make out of this? There I'm going to look at, okay, well, I can see there are 3 big triangles, that's 3 of the bodies, so I can make 3 cars out of that. I can look at the number of cylinders I have. I need 3 cylinders for each race car, so there's 1 race car, 2 race cars, 3 race cars, 3 1/3 race cars I can make out of that. Okay, so I can at least make 3. And then I'm going to look at how many wheels I have. Each race car needs 4 wheels. So I'm going to look at 1, 2, 3, 4. That's 1 race car, 2 race cars, and 1/4. So I can only make 2 race cars because I'm going to be running out of the number of wheels I've got. I've got enough bodies, I've got enough cylinders, but I don't have enough of my wheels to make any more than that. Last thing I should look at is the engine part, the big long rectangle. And I have 1, 2 big rectangles there. So after 2 race cars, I'm going to run out of the rectangles, the engines, and out of the wheels. So those are my limiting reactants. They control how many things I can make. If you look over here at the water example, which is more likely what you're going to see on the AP test, of course, they're going to show a lot of these kind of pictures of different kinds of molecules. Here, according to the key, a double circle represents 1 mole of hydrogen. So if I look at the balanced equation, I'm going to need 2 of those to make 2 waters. So I'm going to look at, well, how many waters could I possibly make with this? For every 1 reaction, I'm going to need 2 of these and 1 of the dark circles. So if I look here, this is 1, 2, 3. I can run the reaction 3 times, and I'll have this guy left over, the hydrogens. I'll have hydrogen left over, 1 mole of hydrogen left over. I will run out of all my moles of oxygen. So my limiting reactant would be my oxygen. My excess reactant is my hydrogen. And in this case, I would have 1 mole of excess reactant left over. Now we're going to look at this problem that I've got down here and do some actual math with it. But the same ideas applies. What I'm going to do to decide what's my limiting reactant is I'm going to test to see, like on the cars, how many cars can I make out of each piece? And with the water, how many waters can I make out of each piece? It's that same idea. Okay, here we are. Here's my balanced equation. I'm going to ask how many grams of water can you make if you have 12 moles of this and 20 moles of the other part? Okay, doable. Here we go. Actually, I meant to say 1.2. Can I switch this to 1.2? Otherwise, it's just too big of numbers. 2.0. Okay, this sounds better. So, how many grams of water? Question mark grams of H2O. Just like I did with cars, I asked how many cars do I have? I'm going to ask myself, well, how many grams of water do I have when I've got each of the parts? How many grams of water can I make when I got 1.2 moles of C3H8? And the other question is, well, how many grams of water can I make if I have 2.0 moles of oxygen? I have to test all of the reactants. In this case, there's 2 reactants, so I have to test, well, how much water can I make from this reactant, and how much water can I make from this reactant? And then we'll see which one runs out, just like we did with the cars. So I have to put moles on the bottom of C3H8, and I'm going to do moles on top, because I got to get to moles of water in order to get to grams of water. In order to go from moles to moles, that's when I have to use a balanced equation. There's a 1 right there, so 1 mole of C3H8 makes 4 moles of water. Then I'm going to get out of moles and go into grams of water. I know that 1 mole of water, if I look at the periodic table number, this grams number is the periodic table number, I get 18.016 by adding up the 2 hydrogens and 1 oxygen on the periodic table. We'll do the bottom part here, then I'll calculate. Moles of oxygen on the bottom, that way they'll cancel. And I want to go to moles of water on top. Balance equation is what I want to use again. There's a 5 for the O and a 4 for the water. Now I can get on moles of water and put that on the bottom, so they'll cancel. Grams of water on top. Periodic tables number, again, is where this goes. 18.016 when I add up the 2 hydrogens and 1 oxygen on the periodic table. And now I just got to put numbers in my calculator. For this top number, I got 86.4768. For this bottom one, I got about 28.8. So looking at sig figs, I got 2 sig figs in both of these. So this is about 86 and 29. So then the question is, well, how much water did I actually make? Basic part of these equations, run 2 equations and pick the lower number. Because after I make those 29 grams of water, I run out of oxygen. Oxygen is my limiting reactant. It controls how much I make. So I can only make 29 grams of water. After I make the 29 grams of water, I have no more oxygen. I can't run the reaction anymore. It's done. Even though the C3H8, I have enough to make 86 grams of water, I can't actually do that because I've run out of oxygen. Okay, so that's my answer to number 1. If we look at number 2, how many grams of excess reactant is left over? Okay, so if oxygen is my limiting reactant, that means my excess reactant is the C3H8. So, first thing we need to do to find the excess reactant is we're going to subtract these 2 values, that 86.4768 minus the 28. If I do that, I get 57.6768. Or if I do the already sig fig spot, 86 minus 29, I get 57. So what we're doing now is we're seeing, if I make 29 grams of water, well, how much of this stuff could I have made? How much more water could I have made with my excess reactant? So I'm going to subtract the 2 numbers. So with C3H8, I could have made 57 more grams of water, or I could have made 57.678 more grams of water. So now that I know that, I can ask myself, well then, how much in, what did I find it in? Grams. How many grams? How many grams of C3H8, my excess reactant, or number 2 here, could I have made from those 57.6768 grams of water that I could have made more had I had enough oxygen? Alright, so here I go. This is straight stoic. I'm going to get out of grams of water, put it on the bottom, and go on to moles of water. I know that 1 mole of water, according to the periodic table, is 18.016 grams. I got to get out of moles of water, put that on the bottom, that way they cancel, into moles of C3H8. According to the balanced equation, there's a 4 for the water, and there's a 1 for the C3H8. And now I got to get out of moles of C3H8 and into grams of C3H8. 1 mole of C3H8, according to the periodic table, is 44.094. That's adding up the 3 C's and 8 H's. If I push all the buttons in my calculator, I get this to be a whopping 35.29. Taking a look at sig figs, now I did use this number to be more appropriate. You're supposed to sig fig at the very end, so but this number is going to have 2 sig figs when I use my subtraction rules. So this number right here really does have 2 sig figs, which brings me to this number should have 2 sig figs. So my end answer would be 35 grams of C3H8. So how much C3H8 will I have left over? I'll have 35 grams of that left over. Looking at number 3. It says, if the lab produced 25 grams of water, what's the percent yield? In other words, how good did you do? In order to percent yield, you're going to take your actual and divide it by your theoretical and times it by 100 to make it a percentage. I remember actual is what you actually get in the lab, that's the experiment number, and theoretical is what you do all this stoic for to get. I remember that actual goes over theoreticals because A comes first in the alphabet and T comes second, so A over T. So looking at what I actually got, it told me in here I got actually 25 grams of water. And I need to look at how much should I theoretically have made. I should have made that 29 grams of water. So 25 divided by 29 times my 100, or technically I should probably use my, not 29 here, your 28.8 to be more appropriate with the sig figs. Try to take the non-sig fig number. 25 divided by 28.8, it got me a 29. No, wait. It got me 86.8, which is equal to 87% looking at sig figs, since I have 2 sig figs, and this one really does have 2 sig figs. So 87%, that means I recovered 87% of the water I was supposed to recover. That's pretty good. If you get 100%, that's like 100% awesome. You got everything you should have gotten. You can get over 100%, that just means you have a contaminant of some kind. Most of the time you're getting under 100%, so somewhere that's up in the upper range. You can see I give myself like a B on this lab maybe. I got 87% of it. That's pretty good. I hope that helped. That's the end of it.